Okay, in this video we're going to introduce our section on polynomial and rational inequalities. We're going to look at polynomial inequalities in this video. So when solving polynomial inequalities, first we're going to find the zeros of the polynomial, and if the polynomial is not equal to 0 at the start of the problem, we're going to have to get it equal to 0. So we may have some terms to bring over from one side of the equation to the other. And then we're going to set up a number line and use test values. So it's pretty much a theme of solving any inequality is we solve it like an equation and then set up a number line and use test values. So we can use that for just about any inequality we come across. So we're going to look at the problem here. 8x cubed minus 2x squared is greater than 41x plus 10. And we're going to write our answer in interval notation. So first up with our problem here, we're going to make it, get it all on one side, all the terms on one side. So when we bring over the 41x and the 10, we get 8x cubed minus 2x squared minus 41x minus 10 is greater than 0. We could have also brought over the 8x cubed minus 2x squared from the left to the right, but we just kept the leading coefficient positive. So if we find our zeros, we can graph 8x cubed minus 2x squared minus 41x minus 10. It'll equal 0 when x is negative 2, when x is negative 1/4, and when x is 5/2, or 2.5. So we set up our number line. We have negative 2, negative 1/4, and 5/2. Well, at those values, if we plug them into the original inequality here, we will get a false statement. So for instance, if we plug in a negative 2, the left side will not be greater than the right side. Same thing with negative 1/4 and positive 5/2. If we plug them into the original inequality, the left side will not come out to be greater than the right side. So they're going to be open circles there. Typically with polynomial inequalities, the inequality sign will tell you what you should have at those zeros. So less than, greater than are typically open circle, less than or equal to, greater than or equal to, closed circle. So now we're going to test out values in each one of these intervals. So we'll test out a value that's less than negative 2, plug it into the original inequality. If it comes out to be true, we'll shade this part of the number line. If it doesn't come out to be true, we will not shade that part of the number line. So we'll test a value from each one of these 4 intervals, and we'll find that between negative 2 and negative 1/4, such as when x equals negative 1, when x equals negative 1, that makes this original inequality true. So all the values between negative 2 and 1 and negative 1/4 get shaded. And then all the values greater than 5/2 will also get shaded. So for instance, when x equals 10, plug a 10 into this original inequality, it will make the left side greater than the right side. Now, as far as visualization goes, we have here we have the polynomial 8x cubed minus 2x squared minus 41x minus 10 greater than 0. If we look at the graph, our answers between negative 2 and negative 1/4 and greater than 5/2 are going to be where the graph of this polynomial is above the x-axis. So it's above the x-axis between negative 2 and negative 1/4, and it's above the x-axis for values of x that are greater than 5/2. So if we get this a 0 on one side and the polynomial on the other, greater than is where is the graph above the x-axis, less than would be where is the graph below the x-axis, and then greater than or equal to, less than or equal to would be at or above or at or below. So we can also use a graph to visualize the solutions as well. All right, so that about does it for this video. Thanks for watching, and I'll see you next time.